Good morning, everyone. Welcome to Tech, AI, and Beyond. Thank you so much for joining us today. In our last deep dive, we took a close look at the smart grid and how we're digitizing our energy future. Well, today, we're zooming out to the biggest consumer of that energy, our cities. Now, cities are fascinating, aren't they? They are, without a doubt, the epicenters of the climate crisis. But, and this is the crucial part, they are also the absolute key to solving it. So in this explainer, we're getting practical. We're moving beyond abstract ideas and breaking down a real, functional blueprint for redesigning the very hardware and software of modern urban life. And to really grasp the scale of what we're talking about, you have to start with this number, 70%. Let that sink in for a moment. Cities, which take up just a tiny fraction of the Earth's landmass, are responsible for more than 70% of global CO2 emissions. They consume over 2/3 of the world's energy. This single, staggering statistic really frames the entire conversation. It shows us, with no uncertainty, the urgency of rethinking from the ground up how our cities are built, powered, and run. So that brings us to the core question for today, the real challenge. If cities are our biggest problem when it comes to climate change, how do we flip the script? How do we engineer them to become our greatest solution? The rest of our time today is going to be dedicated to answering that, piece by piece, layer by layer. And here's our roadmap. We're going to build this out just like a real blueprint. We'll start with the foundational blueprint, the physical structure. Then we'll layer on the digital nervous system and talk about mobility or reclaiming the city for people. We'll even take a look at a fascinating real-world test case in Masdar City. And then finally, we'll put all those pieces together to assemble a blueprint for our collective future. Okay, first things first, the foundational blueprint. Now, this is absolutely crucial. Before we even think about adding a single sensor or writing a line of code, the sustainability of a city is locked in by its physical skeleton, its hardware. You can use tech to optimize in an efficient system, but it can never, ever fix a fundamentally flawed design. You have to get the bones right first. And right at the heart of this new way of thinking about urban design is this incredibly powerful concept, the 15-minute city. It sounds simple, right? The idea is to design neighborhoods where everything you need for your daily life, your job, the grocery store, your kid's school, the doctor, is all within a short 15-minute walk or bike ride. But the implications, they are absolutely profound. This leads to a radical reduction in our dependency on cars, which in turn slashes emissions, eases that soul-crushing traffic, and reclaims enormous amounts of valuable city land from asphalt, from roads and parking lots. And this slide really nails the paradigm shift we're talking about. On the left, you've got the model that defined much of the 20th century, post-war suburban sprawl. It was a model built entirely around the convenience of the automobile. The result? It's incredibly resource-intensive and, in many ways, socially fragmented. But on the right, you see the alternative that green urban planning pushes for, compact, mixed-use cities. These are places designed around the human experience, not the cars. They are inherently more efficient, and they naturally foster a stronger sense of community. Now, a truly sustainable city isn't just dense and efficient, it's also alive. And that's the core idea behind what's called biophilic design, the intentional act of weaving nature directly into the urban fabric. And listen, this isn't just about making things look pretty. It's a critical engineering strategy for combating something called the urban heat island effect. This is a real phenomenon where all that dense concrete and dark asphalt absorb and radiate so much heat that they can make our cities dangerously, sometimes lethally, hotter than the surrounding countryside. So when we talk about green infrastructure, we're talking about so much more than just a few trees in a park. We're talking about a network of functional, living systems that are integrated into the city. Green roofs act as powerful insulators for buildings and absorb massive amounts of stormwater. Living walls do the same, providing cooling and creating new habitats. And urban forests? They're like natural air conditioners. They provide shade, sure, but they also cool the air through a process called evapotranspiration, which is basically plants sweating. It's an incredibly powerful cooling mechanism. It's literally engineering with nature. Okay, let's zoom in from the city scale to the building blocks. The Passive House Standard, or Passive House, is a total game changer for architecture. And what I find so fascinating here is how these 5 principles work together to create a perfect system. You start by making the building's outer shell, its envelope, virtually airtight. You do this with super insulation, high-performance windows, and by eliminating any thermal bridges where heat could leak out. Then, and this is the genius part, a heat recovery ventilator constantly cycles in fresh air while transferring the heat from the outgoing stale air to the incoming fresh air. The result? You get a building that's so incredibly efficient it needs almost no active energy for heating or cooling. It's just comfortable. And when you combine this with things like building integrated photovoltaics, the building can actually become a net positive powerhouse, generating more energy than it consumes. All right, so we've got our sustainable skeleton. The bones are in the right place. The question now is, how do we make it intelligent? How do we make it responsive and adaptive? Well, that's where the city's software comes in, its operating system. And that brings us to the digital nervous system, powered by the Internet of Things and, of course, artificial intelligence. I think this quote just frames the relationship perfectly. Think about it. A city-wide network of millions of sensors, on lampposts, in pipes, on buses, all generating a constant, real-time stream of data. That's the pulse of the city. It's the sensory input. This data allows city managers to make a fundamental shift, from just reacting to problems after they happen, to proactively and intelligently optimizing everything from traffic flow and waste collection to energy and water use. It's a whole new ballgame. Let's look at a really tangible example: waste collection. Traditionally, it is unbelievably inefficient. Garbage trucks just run the same route every single day, whether the bins are full or empty. But with smart waste management, you embed ultrasonic sensors in the bins to report how full they are. When a bin hits, say, 80%, it sends an alert. Then an AI takes all that data and calculates the most fuel-efficient collection route for that specific day, dispatching trucks only where they're needed. This one application can cut collection trips by up to 50%. That's half the fuel, half the emissions, half the traffic. It's a massive win. And the savings are just as dramatic with smart street lighting. Instead of having every light burning at full power all night long, streetlights equipped with sensors and network connectivity can dim down when nobody's around, and then instantly brighten when they detect motion from a pedestrian or a car. This simple change can slash a city's street lighting energy consumption by 40 to 60%. And you can apply the exact same principle to water systems, using acoustic sensors in the pipes to listen for the telltale hiss of a leak, allowing crews to fix it before millions of liters of precious treated water are lost. Okay, so we have a smart skeleton. Now let's talk about how people move through it, the city's circulatory system. For the better part of a century, we've designed our cities around one thing: the car. The sustainable city completely flips that priority. It's about creating an integrated, multimodal system that is designed first and foremost for people. And if you think a massive cultural shift away from cars is just some urbanist fantasy, you have got to look at Copenhagen. More than 60% of its residents commute to work or school by bike, every single day, in all weather. And this did not happen by accident. It wasn't some fluke. It was the direct result of decades of deliberate, consistent policy, design, and investment. So, how did they do it? What's the secret formula? Well, it's actually pretty straightforward. They focused relentlessly on making cycling the safest, fastest, and most convenient option. They built physically separated cycle tracks on pretty much every major street so you feel safe. They created bike superhighways for people with longer commutes. They even redesigned intersections to give cyclists and pedestrians priority over cars. And here's a stunning fact: independent studies have shown that this massive investment actually pays for itself in public health savings alone, from a more active population. Copenhagen proved a simple but profound truth: if you build it, they will come. If you build world-class infrastructure for people, they will absolutely use it. Now, this focus on clean transit isn't just about bikes. Over in China, the city of Shenzhen offers a remarkable case study in electrification at a massive scale. It became the world's first major city to electrify its entire public bus fleet. We're talking more than 16,000 buses. In one single move, they dramatically cut both local air pollution and noise pollution across the entire city. It's a testament to what's possible with focused public policy. So retrofitting existing centuries-old cities is one massive challenge. But what happens when you get to start from a completely blank slate? Well, that brings us to Masdar City in the United Arab Emirates, a project that was designed from day one to be a living laboratory for green urbanism. Masdar's design is this really fascinating blend of ancient wisdom and cutting-edge technology. On one hand, it uses traditional Arabian design principles, like building narrow, shaded streets that are perfectly oriented to catch prevailing winds and create natural cooling breezes. That's passive design. On the other hand, it's packed with modern tech: a huge solar farm, a completely car-free city core with futuristic personal rapid transit pods and electric shuttles, and incredibly sophisticated water recycling systems. Now, it's fair to say that Masdar has faced its share of criticism and it hasn't quite lived up to its original lofty goals. But to dismiss it would be to miss the point. Its true value isn't in being some perfect cookie-cutter model that every city can just copy. Its value as a real-world R&D platform. It has provided invaluable, hard-won data on however 1,000 different clean technologies actually perform and integrate with each other in a demanding, real-world urban environment. It's a priceless learning experience. Okay, so let's pull all these threads together. We've looked at the skeleton, the nervous system, and the circulatory system. Now let's assemble that final blueprint for the cities of tomorrow. It really boils down to these four interconnected pillars that we've discussed. It all has to start with the physical foundation of green urban planning. That's the skeleton. On top of that, we layer the intelligence, the digital nervous system of an IoT-powered smart city. We then enable it all with a sustainable mobility system that puts people first. That's the circulatory system. And all of this is run with intelligent resource management, creating a kind of closed-loop metabolism for the city. Ultimately, the vision here is for a city where a high quality of life is completely decoupled from having a high environmental footprint. It's a city that is efficient by design, that deeply integrates nature into its very fabric, and that, above all, prioritizes the human experience over the convenience of the automobile. You know, when you look around the world, from Copenhagen to Shenzhen to Masdar City, you see that pieces of this future are already being built. The technologies exist. The design principles are well understood. We literally have the blueprint. And so the only question that really remains is, do we have the collective political and social will to start building it at scale? So let's summarize. The most critical takeaway here is that the sustainable city isn't about finding one single magic technology. It's not a silver bullet. It is an integrated system. It's about combining a green physical foundation, a smart digital overlay, and a mobility network designed for people. When you get those three core things right and make them work together, you build a resilient, efficient, and truly livable city for the future. Next time, we'll be exploring the circular economy, closing the loop, which is the perfect follow-up to our discussion today. Thank you so much for watching. If you enjoyed this, please subscribe, like, and share, and don't forget to hit the bell for more from Tech, AI, and beyond.